All right. So, Kaveri, what was the last thing you noted? Like, let me know once you finish till here. So this is
this is real.
okay. So this is quite important to differentiate about these values x and y. So x and y, they may or may not be equal to the coefficients a and b. Also, they are only determined experimentally. There's no shortcut way just by looking at a reaction, like, okay, kya ho sakta hai? And once you know the values of x and y, you can integrate it in order to get the rate of a reaction at a specific time t. So the formula that you get would be the integrated rate equation. So we'll be looking at that also in this section. Okay. So when we talk about rate law, so this is the equation. Law matlab there is a statement also that like what is rate law. It is basically this mathematical equation put into words. Yeah.
What is the point of writing x and y may or may not be equal to a and b?
Because it's important to know that, like, it's likely, you might get
But
confused.
shouldn't they be equal? I mean, that's how we write the concentration, right? The stoichiometric coefficient.
It's not like that's why I've specifically written this. In order to figure out how the rate varies with reactants, with the concentration of reactants, you can't always get it directly from the reaction. So x and y may or may not be equal to a and b. You can only figure it out experimentally. Because it depends on a lot of factors. It's not just if you have a molecule of a and a molecule of b, it's not necessary that they will collide with each other compulsorily. It depends on how much energy it is. Like temperature was one of the factors. So at a particular temperature, unka, like you have that whole distribution of velocities, right? Some molecules will have enough energy to collide with the others and form a new molecule. Not all molecules like will have that much amount of kinetic energy with them. हर एक का अपना properties होते हैं, like when you get right down to the molecular level. So it's not something that would be standard for all the compounds. That's why you only need to figure it out experimentally to see, okay, what is the factor here by which it depends. Okay. So it's not something you can get directly from a
When we wrote for like solubility, when we wrote for KSP and all, it always used to be if it's 2 NO2, suppose.
used
It
to
always NO2 raised to 2.
So yeah, like in so there we're looking at the forward reaction, backward reaction. Again, they may or may not be equal to a and b, right? Like in some cases you get it directly equal to whatever is the stoichiometric coefficients. In many cases it's not always.
What did you say about kinetic energy?
No, so again, going back to how reactions take place, the molecules need to collide with each other in order to react. they need to collide with a certain energy so that one bond breaks and the other bond forms. तो उस energy होने के लिए, like when they collide, they need to have enough kinetic energy. So all molecules will not have. So even when I did the simulation, all the molecules that crossed paths have not turned into products. Like by the end of the reaction, we got like 2 or 3 molecules of the products out of 5 or 10 that we took.
A little twisted question. So can we conclude that if we increase the temperature, the energy that we supply to the reaction, then there's a higher chance of XY being equal to AB?
Not really.
But then they'll be provided by the kinetic energy that they require, right?
Yeah. So I'll have to look into it, like because temperature also is like it has its own thing. But I've never heard of the relation between this and kinetic, like order and the kinetic energy together. Let me see. Okay. Okay. So rate law statement. Okay. We'll just like I'll give it to you guys, but I don't think I've ever seen a question just asking state the rate law. The mathematical equation is the more important bit. This is the one that will be used asked in questions a lot of times. Yeah, if you want, like it's an expression in which, so an expression in which the reaction rate, so that's the LHS, the reaction rate is given in terms of what is it given in terms of? The molar concentration of the reactants, which is the concentration of A, concentration of B part of it, with each term raised to, okay, can you guys see Nietzsche? Should I go to the next part?
We can see.
Okay, all of you?
Yes, ma'am.
Raised to some power which may or may not be equal to the stoichiometric coefficient. So this is the rate law. It's literally this written in terms. So rate of the reaction given in terms of the molar concentration of the reactants raised to some value, some powers which may or may not be equal to the stoichiometric coefficients. See if there's any questions based on rate law.
Miss, I didn't still didn't understand may or may not be equal to coefficient, coefficient, yeah, stoichiometric.
Okay, I'll see if there's any examples. Can see. Okay, book में ठीक है. Right, I'll show some examples. If once everybody's done, we'll switch to the next page and give some examples. Done? Sanskriti? You can see no one is writing. I'll just switch then. So it's like all these examples I'm picking up from the book only. So one reaction, nitrous oxide, not nitrous is basically NO, when oxidized turns into nitrogen dioxide. So apparently iska rate law, so rate is equal to, so K into concentration of NO square, concentration of O2. So in this case, it happened to be equal to the stoichiometric coefficients. But there are a couple of other reactants. So halogenation, substitution reaction, free radical halogenation. So CHCl3 chloroform plus Cl2 gives CCl4 plus HCl. But iska rate is equal to K into CHCl3 into chlorine raised to the power half. In this case, it is not the same as your stoichiometric coefficient.
But why? How?
Why? How? Matlab, like experimentally it is determined, like by changing the concentration of CHCl3 alone, you figure out, okay, how is the rate being affected? Then you change the concentration of Cl2 alone and then figure out, okay, how is the rate affected? So we say experimentally, when they did the calculations, when they checked the rate of the reaction in each case, they found that, okay, this is the way in which the rate has been changing. So that's what it means by
But like,
experimentally.
yeah, but that you can only find like like if you were given an equation and you're supposed to write the rate of like equation, so then how would you know?
No, you can't. That's the whole point of saying it's only experimentally determined. Just by looking at a reaction, you can't predict what the rate law will be. Okay, that's the thing. That's why we've specified. So even the opposite saponification reaction, like esterification ka opposite, when an ester, so CH3COO C2H5, in the presence of water, breaks down into its corresponding acid and alcohol. So esterification का opposite है ये, like hydrolysis of esters. इसका rate law, it only depends on the concentration of the ester, not on how much water you have given it. And H2O raised to the power 0. So as long as water is the medium, it gets like the rate of the reaction is not affected based on this. So it's independent of the rate, like the quantity, concentration of water, the quantity of water. Okay. So that way, like that's the point of mentioning it may or may not be equal to the stoichiometric coefficient. So you do have cases where it is equal, but you do have cases where it's not as well. So the only way you can figure out what X and Y is only by experimentally. That's it. Okay. All right. So next, we'll talk about order of a reaction. So depending on the rate of reactions, you can classify them as being first order, second order, zeroth order, like all of that. Okay, so it completely on the basis of the chemical kinetics, like depending on what the rate law is. So order of a reaction, just by looking at the rate law, you can figure out what is the order of the reaction. So order of reaction is simply x plus y total. So rate law में concentration of A power x, concentration of B power y, जितने भी reactants है सबका exponents रहेगा ना. So you add up all these exponents and what you get is the order of the reaction. Okay. So x plus y is basically अभी जो rate law में लिखा है those values. So depending on what the order is. So if order
Just
equal,
1 second.
finish it up, then go on next part.
Factors affecting reaction हो गया.
We are taking it one by one, right? I started off with the concentration.
Yeah.
Concentration dependency is on the basis of these exponents x and y, right?
This order is under what?
So x plus y is called order. So like pura concentration ka hi part hai. So order of a reaction will give you an idea ki how much is the dependency of the concentration. Okay, so if order of a reaction is very high, then if you increase the concentration of reactant by a little bit, any of the reactant, then you know that rate is going to increase quite a bit. But if order of reaction is low, or even if order of reaction is zero, then you can say that acha, like whatever you do to the concentration, the effect is not going to be that much. So this will numerically place you how much is that dependency. So order of a reaction is equal to x plus y. Okay. So if order is zero, matlab exponents is all.
Wait 1 second, the last one. Done.
Okay. So if order is zero, so exponent pura zero ho gaya, right? Like x, y pura zero ho gaya. This means that rate will be equal to k. So anything raised to the power zero is 1. A power 0 is 1. Matlab constant, like it has become independent of the concentration. The rate is a constant. So how much ever reactant you take, the speed, like kitna time mein product form hoga, that's going to be constant. So R equal to K, matlab rate became constant. So if it is non-zero, then it depends on kitna reactant hai, becomes dependent on the concentration of the reactant. So in this case, it means that rate is independent of the concentration.
If there is no like x and y, then
Yeah. So order equal to 0 ho gaya. So yeah, x and y ka value 0 ho gaya, becomes independent. So examples, let me look up.
I don't understand if X and Y, which we found experimentally, that is 0, then how is rate independent of concentration? Because there's no raise to X and no raise to
Yeah.
Y. But still, yeah, it's independent.
Dependency nahi hai, so it's independent. So now, no matter how much of the reactant you use, the rate is going to be the same. So then if you want to speed it up, you'll need to look at other things using catalyst, using temperature, like other things. So concentration is not going to help you there. So one of the previous examples that we saw, decomposition of HI is a zero order reaction. So 2HI decomposing into H2 and I2 is a zero order reaction. We also have decomposition of ammonia, formation of HCl, like all of these are zero order reactions. So I'll give you guys more examples when we get to it. So zero order reactions, these sort of reactions, and first order reactions. So we'll be looking into only these two types of reactions in detail. So we'll look at the integrated rate law and all of that. Okay. This when it takes place over gold catalyst. Yeah, so this is an example. Elementary and all, we can look at it afterwards. Okay. So we brought in a new quantity K, right? So what do you guys think about units of K? What will be the units of K, rate constant? Work it out. You already know the rate law. Write it here. So rate equal to K into whatever concentration of A, B, like you have the order, right? So you know the unit of the rate of a reaction, you know the units of concentration. You need to find the units of K. So put it in the equation and figure it out. Kya hoga?
Is that AU on top of the arrow?
Yeah. So this decomposition, you do it over gold catalyst.
Liters per mole second.
Okay. Is that the only one, like definite, proper?
Sorry.
Is that your final, like, is that the only unit? Is that your final answer?
I mean, by concentration, if we do by moles per liter, then one cycle test.
Don't forget about X and Y here. Keep that in mind.
What about X and Y?
So if you do it, like, work it out mathematically. Rate ka unit kya hai?
Moles per liter second.
Mole per liter second is equal to K is what we need to find out. What would be the unit of mole per liter? But it's not just mole per liter, no? So this is raised to the power X. So this also will be raised to the power X. And similarly, B also mole per liter raised to the power Y. Okay. So by rearranging, So the unit will be mole per liter upon, so mole per liter per second divided by mole per liter raised to the power x and 1, x plus 1. So the unit of the rate constant will depend on the order of the reaction. Okay. So agar order 0 hai, so this will not be there. So it'll just be mole per liter per second. Agar order
Why is the
Hmm?
why do you say it like mole per liter per second? Isn't the second like with the liter in the denominator?
Yeah, you can say that adat ban gaya, like rate is concentration per second, right? Let's say meter per second, kilometer per second. Isliye mole per liter is the concentration per second. It's just a habit. Okay, but so if it is just, if the order of the reaction is 1, means that x plus y equal to 1. So ye pura cancel, okay? Unit of rate constant is just second inverse or per second. And then if the
Sorry.
order is,
What is the point of the example that you've given? HI wala?
this is an example where the order of the reaction is 0. So this is the example of 0 order reaction. Okay, so the units of rate constant essentially depends on the order of the reaction. So if you know the order of the reaction, put the values there and you'll get the units of rate. So this is another way to figure out the order of a reaction. So if you know the rate constant, if you have found the value from a resource, then by looking at what are the units of the rate constant, you'll have an idea what is the order of the reaction. So you can work your way backwards from there. You can use that suitable rate equation, rate law in order to solve your problem, like apply it in your thing. Okay. Okay, so we'll do some questions, like get you guys used to this. So iske baad we'll get into the molecularity. Actually, we'll finish off molecularity. That's also pretty simple only. And then we'll do the, like we'll start 0 order, first order reactions and all tomorrow, freshly. We'll finish off this thing. So this is order of a reaction, which is basically the exponent on which the rate of a reaction depends, the exponent of the concentration. So now to figure out the molecularity of a reaction, there's something called molecularity of a reaction. So molecularity of a reaction is, to put it very, very simply, it is the number of molecules, like individual molecules required for the reaction to take place. Okay. So officially, okay, what is molecularity of the reaction is the number of reacting species taking part in an elementary reaction. So it's like how many molecules must simultaneously collide with each other so that you get the end product, so that the reaction takes place. That is molecularity, if you have to have an understanding of it. Okay. Yeah. So based on molecularity, like order of a reaction, that relates to the chemical kinetics, rate of a reaction and all that. Molecularity, it's literally just how many molecules are required for that reaction to take place. So based on the molecularity, you have unimolecular, bimolecular. Do you guys remember these words? Have you come across this? Let me write it properly only.
SN1, SN2.
Yeah. So that there we saw, okay, how many molecules need to collide simultaneously for that reaction to take place. So you have unimolecular, bimolecular, trimolecular, and that way you can go on, like depending on how many molecules are required. So I mean, bringing it back to SN1, SN2, they're very good examples to show this. So SN1 is substitution nucleophilic. This is unimolecular. So SN1 में क्या होता है? Like, do you guys remember the what do you call it? Mechanism. What happens in unimolecular?
Backward atom.
Huh?
No, nucleophile formation.
Nucleophile formation, right? So unimolecular में, for that reaction to take place, like the rate determining step, the slowest step, like what determines whether that reaction is going to go ahead or not depends on the formation of the nucleophile, right? Nucleophile, what am I saying? Formation of the
Carbocation. Yeah.
carbocation, yes. It depends on the formation of the carbocation. And carbocation formation may, how many molecules are involved?
Sorry?
So formation of the carbocation may, how many molecules are involved? Like, do you have a carbocation forming when two molecules collide with each other, or three molecules collide with each other? Or like, how many molecules are involved in the formation of a carbocation? Like, suppose I have,
When the carbocation is formed, the nucleophile doesn't have any role. Nucleophile trapped after the carbocation. Like that.
so if you have C and then Cl, if you want to convert this into a carbocation, what needs to happen? Like, do you have another molecule colliding against it? क्या होना चाहिए? Smera.
Smera is done.
I'm zoning out.
Oh wait, you don't have organic coming up in this exam, no? Okay. Here. So like what happens when you want to, like, where does the carbocation form? In one of these or here, like this carbon? कौन सा carbon पे you have the carbocation forming?
First, like the initial carbon, because it will form like tertiary carbon.
The one like initial matlab like starting from left to right, right to left, like which?
No, right too.
The one where chlorine is attached.
Yeah. Oh, that's a chlorine. That okay, sorry. Yeah, the one where the chlorine.
So you have CH3 tries, C plus and Cl minus. So इस step में how many molecules were involved in this step? Did you have something else coming and hitting this in order for this bond to break? Like it depends on all of just this molecule. No, it depends only on one molecule. So this is called like substitution nucleophilic. Substitution क्योंकि substitution हो रहा है. What is substituting? Nucleophile is substituting. Unimolecular because it only depends on this alone. So iska molecularity is 1. So that's an example of unimolecular reaction.
Sorry, could you repeat that?
So substitution nucleophilic, ठीक है, substitution reaction is taking place. Nucleophile is coming and substituting it. The third part, the unimolecular part is coming from the fact that iske chemical kinetics mein, in order for this reaction to happen, you only need this one molecule alone to kickstart the reaction. Like it's dependent on only the reaction of this molecule alone. So molecularity is 1 in this particular case. So the rate determining step, the slowest step, once it crosses this hill, once it splits into a carbocation, the reaction will happen. So
This is dependent on one molecule, so we call it unimolecular. So
Yes.
in SN2 also it's dependent on one.
Is it? That's what I'm going to come next. Bimolecular. SN2 में क्या हो रहा है?
Backward attack
By the same molecule, different
by
molecule,
the nucleophile.
by the nucleophile. So the nucleophile, unless and until it comes and collides against this from the back, this reaction is not going to go forward.
Oh, yeah.
So-
For formation of carbocation, ऐसे अपने आप only it becomes like C के ऊपर plus आ जाता है. There's nothing, no reagent or catalyst being.
मतलब that's why you
In the
medium. That's why you take the right kind of medium, like reaction conditions in. But essentially, like if you're looking at the number of reacting species, only depends on this. Once it's in a polar environment, it's gonna split on its own. इसलिए. In
This
this
is a
case,
polar environment.
like water, like where you have that polarity so that the ions can be formed and